Hello everyone. In the previous video, we learned about the four classifications of machine learning: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. In this section of the course, we will learn about the overall process of machine learning. Due to the relatively large amount of content in this section, so we may split this machine learning process into two videos to introduce the overall flow to everyone. I believe that through the learning in the previous two sections, many students will have a general framework for machine learning. So the purpose of this section of study is to strengthen the rough framework you have already formed and make up for the missing parts. So the overall process of machine learning, that is, the various parts listed on this film of ours: data collection, data cleaning, feature extraction and selection, model training, testing and evaluation, final deployment and integration. Then we will find that among these middle ones, they have the same color, and there is an arrow indicating it is for feedback iteration. That is to say, data collection, the data we collected initially, is exactly as it is. Finally, the deployment and integration of the model, also related to our final work. Our machine learning algorithm, the key focus, is on these four central parts: data cleaning, then the selection of features, model training, testing, and evaluation. If the result is not good, iterate again. You need to clean the data again, select some better features again, then train the model again and evaluate it, until the model you eventually form can meet your requirements, meet the requirements of actual projects. Then your entire machine learning process is considered complete, finally formed an effective model. So for this lesson, we'll also focus on elaborating on these four intermediate processes. First, let's take a look at the data set. What is a data set? A data set is a set of data used in machine learning tasks. Each piece of data is called a sample, reflecting issues related to the performance or characteristics of the sample. Or, in other words, attributes are called features. So, what is a data set? The data set is the same basket we obtained at the beginning, that pile of data. In the data, some of its attributes, we refer to each attribute as a feature. Next is the training set. It is the data set used in the training process. The data we initially received, it is the biggest concept, which is the data set. So our data set needs to be split. The simplest way to segment is part of the training set, part of the test set. The training set is used for training. We just saw that we need to iterate the whole process, right? In the iterative process, time and time again, we are using the training set data to optimize through continuous iteration, continuously optimize the parameters inside our model. What is the test set used for? After learning the model, the process of using it for prediction, call it a test. In other words, during the testing process, need to use data? You always need to put in a piece of data to check. I gave you a piece of data. Can you come up with a correct result? The data set used in this process, pay attention to the data set used at this time. We refer to it as the test set. At this point, there is a very crucial issue. Is it permissible for the training set and the test set to have intersections? Intersection, attention. This is absolutely not acceptable, absolutely not possible. Intersection is not allowed. The training set is the training set. The test set is the test set. Their data cannot have any intersection. If you use the trained data for testing again, then your results will be very good. This way, your test results will be authentic. Next, let's take a look at an overview of the data. This is the most typical style of a piece of data. 1 by 1, 1, 2, 3, 4, 5. Data like this 1 by 1, I divide the above four data into a training set. The fifth data is used separately as the test set. During my training, I use the first four pieces of data. When I test, I only use the fifth set of data. No intersection at all, so in this piece of data, it may have area, school district, orientation, and final house price. So I might consider area, school district, and orientation as its three features. My goal is to obtain, or rather to predict, the price of a house. So the final price is its tag, and all the properties related to this house. Its area is also good. Regarding the school district, no matter the direction, all of these serve as its features. This is a data set, its original appearance. All data sets are like this. For supervised learning data sets, it is under the label column. If it is unsupervised, then it has no label. Then you need to use this type of algorithm, simply learn to target its features. So we've talked so much about data. Why is data so important? We need to emphasize data in this way. This is what we embody. In our first sentence, data is crucial for the model. Please remember this word, crucial. It is the ceiling of model capability. Without good data, there can be no good models. Many of our students may encounter some problems when working on projects. No matter what algorithm I use, no matter what method is used, I never get a good result. At that time, it may not have been an issue with your model. It's an issue with your data. In the field of machine learning or artificial intelligence, there is a very popular saying, "It's the model you've built or the results you've produced. Just try to fit the distribution of your data as closely as possible. Fit the distribution of your data as closely as possible. It is impossible to perfectly fit the distribution of your data. You are just fitting as closely as possible. Your data is what determines the outcome of this project, or the key to whether your final model is good or bad. You provided a bunch of bad data. It has a lot of noise. It has a large number of missing values. Then you won't get a very good result with any model." This is the importance of data. So data preprocessing, in order to improve our initial data that may not be very good, processing it into data that is very beneficial for our model. So it is mainly divided into these parts. Data cleaning, fill in missing values. It is possible that in the process of obtaining this data, some values are missing. So you want to fill in, based on experience, A5, fill in a value in the middle of 7, fill in a 6. What other ways will there be? Discover and eliminate the data and abnormal points. What is an outlier? A5, a 7, with a 10,000 in the middle. So it's a normal person in terms of data. Or, to put it another way, a normal piece of data. It will be found that there are actually some problems with this place. It may be a noise point. Cause such, there is a value of 10,000 like this. So at this point, we need to clean the data. What is the other one? Dimensionality reduction of data. Simplify data attributes. Avoid dimension explosion. What does this represent? Just now, everyone can recall the video from the previous section. We have created a small example. We differentiate between men and women, some of the data dimensions. Or there are some features of the data. I wrote about a leg and a face. Is there a section on legs? Is it necessary to judge a person based on this kind of data? Especially when our data consists of men and women, I believe that all data may have this item, legs. At this time, this dimension of data, features of this dimension, it is just unnecessary. So we need to reduce its dimensionality, simplify our data, because it has nothing to do with our results. Avoid dimension explosion at this time. Why avoid it? With each additional feature you have, you need to perform calculations. This is for your computational loss, or it could be a significant loss to your computing power. Just now we talked about deleting some features. This belongs to low variance feature filtering. Simply delete these low variance features. And sometimes we are using some other methods to reduce dimensions. For example, PCA dimensionality reduction, it achieves this by integrating certain features. Achieve a new feature, then achieve a dimensionality reduction effect. Another data standardization, standardize data to reduce noise and improve the accuracy of the model. Why is it said that standardized data can reduce noise? Let's continue with the example we just used, 5, 10,007 such a data arrangement. If we know at this time, our data will fluctuate around 0 to 10. So it's very simple. I set 0 as 0, I'll just set it to 1. All the data in between. Standardize according to this range between 0 and 1. I don't care how much noise there is in here. 1,000, 10,000, or even a million. So you are greater than 10 in the end. I calculate everything as 1. Can it reduce the impact of noise here? Although this 10,000 here may be a 34, normalize it to 1. There may still be some impact, but at least it is much less impactful than the previous 10,000. So, in this way, it can indeed improve the accuracy of our model. So, the workload of data cleaning, here is a pie chart to show everyone. This is also why, or to put it another way, this is also what we are emphasizing here. Once again, data is very important. In the process of building a machine learning model, data scientists reshape 3% of the training set, 5% is doing other work, a relatively large 19% collection dataset. Collecting datasets is also a very important task. You can form a very good dataset. It is a significant contribution to scientific research. Optimize the remaining 4% of the model. Discover patterns in data, accounting for 9% of the total. What is the other 60% for? It is about cleaning and organizing data. You need to constantly review your data. Is it a very good data set? A large amount of work is spent here, so we see a lot of work being spent on the process of data cleaning. What does data cleaning mainly do? Mainly did filtering and missing value processing, outlier handling, merged data and data aggregation, data filtering, data missing, data anomalies. We have just been introduced, right? Mainly to remove some noise, fill in some missing values. What does merging data from multiple sources refer to? Your data may come from more than just this aspect, may come from multiple data sources. You need to merge and summarize it, summarize the data, form a complete data set. Sometimes your data may depict only a part of the entire data set. So many data sets are needed to form a complete data set. To make your data free of any discrimination, or your data is unbiased data. This is what makes a good data set. This is the work of summarizing and merging data sources. When it comes to data cleaning, the term dirty data must be very common. We often hear such a statement, dirty data. So what is dirty data? Mainly, there are incompleteness issues in data quality. High noise level. In this inconsistent situation, we refer to this data as dirty data. So here is an example. We can go through them one by one. Indeed, it refers to very typical dirty data. There should have been a value here originally. No more. Invalid value. Here, the gender should be male and female by itself. There is an extra A here. This A has no clue at all. Are they aliens? This is an invalid value, should be in the value of another column. What does this mean here? In Italy, this should be in the country rather than in the city. So this value is placed in the wrong position. This is also obviously dirty data. Incorrect spelling. Clearly, this is a spelling mistake. It does not exist in any country. No country has this word as its name. There are also attribute dependencies. This is obvious, like this value. It has attribute dependency. These two features clearly exhibit attribute dependency. So this is also incorrect. Format error. Like this, we humans can understand such data. However, in the field of computers, usually we would require that a column of attributes all follow a certain format. Then you use another format humans can understand, but computers cannot. And this one, invalid duplicate item. We all know about this ID column. It cannot be duplicated. Or you may specify one of your attributes. It is all unique values. You have duplicate entries. This is clearly a mistake. Okay, the next topic is data transformation. After this initial pre-processing of the data, after the cleanup work. We need to convert a lot of data into some machine learning models, commonly used forms of expression, for example, the first type. In classification issues, we need to perform one-hot encoding on the categories. What is the other code called? Called one-hot encoding, also known as one-hot encoding. What kind of method does dumb encoding adopt? It's a category. We all know that categories may have 1, 2, 3, 4, or 5 types. But the computer won't recognize this. What do we usually do? If you want to do two types, men of this kind, women of this kind, what is dumb encoding? Being a man means being strong. Female is 0-1. All men are 0-0. Woman is 0-1. What is one-hot encoding? This is one-hot encoding. This is one-hot. When it's hot, man is 1-0, woman is 0-1. In other words, the biggest difference between gray code and one-hot encoding is the dumb encoding uses only 0-0. One-hot encoding. How many types do you have? I have a long string of numbers, like 0-1. Which category do you belong to? I'm just in that position. Set 1. 3 types of one-hot. It's 1-0-0, 0-1-0, 0-0-1. 3 types of dummy coding. It's 0-0-0, 1-0, -0, 0-1, -0. Like this, in other words, we need to convert the category for it, because it has transformed into this appearance. This is the way that machine learning models recognize it. Convenient for us to deal with many softmax functions later on. This is the follow-up. So, the next one, it is to convert numerical data into categorical data. To reduce the corresponding value, we all know age. We may exist from 0 to 100 years old, but sometimes we don't need to distinguish so finely. We may only need to know the teenager, middle-aged, elderly. Just okay, so I can divide the age range from 0 to 30 into one group. 30 to 60 years old is considered as one. Divided into one group from 60 to 100 years old. I use the original multi-classification data, become a 3-classification data. This is the transformation of data. Are there any others? For example, extracting useful data from text data, bag of words that can be used, Word2Vec, etc. It's all about you needing to spell a word, man, woman, China, foreign such words, converted into data recognizable by a computer. Like Word2Vec, it's to convert the vocabulary we just used into a series of numbers. Replace our original data with this string of numbers. So when processing image data, various features that you have formed, color features, HAR features, etc. This converts the original pixels into other features. At this point, this introduces the concept of feature engineering. It is to normalize our original features. Standardization ensures that the codomain of different input variables of the same model is consistent. This is a very important point in feature engineering. The place you used to have is the input word. Some places input numbers. After feature engineering, after the data transformation, we turn it into inputs with the same value range, features of inputs with the same value range. Sometimes there will be some feature expansion. For example, at the beginning, I only had pixel features of this color. So I regenerated some HAR features or some other features, right? This is the expansion of features. Feature selection. We have just done a lot of feature expansion and feature selection. Is there a necessity for this thing? It is very necessary. Usually, in most cases, in a dataset, there are many different features. Sometimes these features may be redundant, or the situation that is unrelated to our predicted values. At this point, we need to perform feature selection. It can simplify the model, make the model easier to interpret. It can also avoid the issue of dimension explosion, and then you can also reduce the training time, right? The amount of data is reduced, so the training time is naturally reduced, and it can enhance the generalization of the model, methods of feature selection. This photo begins to introduce the methods of feature selection. The first method is the filtering method. On the left is the overall process of filtering method. It traverses all features, then find the features, such a correlation between it and our results. The most important point, relevance, is here. Relevance. Assess the relevance of each feature to our target attribute, arrange by the size of relevance. Retain highly relevant features. Selected the features we need in the end. It is unrelated to the model itself. Its prerequisite is that our features should be independent of the model itself. The common method is Pearson correlation coefficient. Kappa coefficient Mutual information and other methods. The limitation of the filtering method is that it tends to select redundant variables. It does not consider the relationships between features. Once one of your features is highly related to the target attribute, at the same time, you have other features that are highly correlated with this feature. So the result selected by the filtering method is to select all the features in this round. So actually, the set of features you have selected, it is still very redundant. This is the filtering method, its approach, and its drawback. Next is the wrapper method. Wrapper means wrapper. What is the packaging method like? It treats the entire feature selection as a search problem. It first traverses all features, then generate feature subsets, then go to see the performance of this feature subset. It is scored based on the accuracy of the model. You have generated many feature subsets. Further scoring based on the accuracy of these feature subsets. Select a more accurate subset of features. As the final result, a common method is feature elimination by recursion. Packaging method also has its limitations. Packaging method is a very computationally intensive method because it needs to perform a calculation on each subset, so its computational workload is very high. What is another limitation? Its feature selection method is usually specific to a certain type of model, provided the best performance characteristics. In other words, its specificity is too strong, too specific. This will result in insufficient generalization ability of the entire model. All right. Next, let's take a look at the embedded method. Embedding method, the method of embedding, is to incorporate feature selection as part of model construction. How is it accomplished? Just like the image displayed on the left side here, it first generates a feature subset, then use learning algorithms to conduct an effectiveness evaluation. If the performance is not good, generate another subset of features. Proceed with another evaluation. In other words, embedding the process of feature selection into our model construction process. So the most common method is our regularization method. You should still remember L1 regularization and L2 regularization. L1 and L2 regularization are behind our lasso loss function. In addition, with L1 regularization or L2 regularization, just completed the process of feature selection using the embedding method we just discussed. So the most common one we all know. If linear regression is combined with L1 regularization, it is lasso regression. If combined with L2 regularization, linear regression combined with L2 regularization, it is a ridge regression. All right, so that concludes one of the main topics of this section. So in the next section of the video, we will continue to explain the overall process of machine learning algorithms. Okay, thank you. Goodbye.